You don't have to, don't write it down. There'll be a, you can write it down tomorrow when you get your actual packet, but just keep in your mind a week from today is going to be your first quiz. All right, a week from today will be the first quiz, and then the test will be when the Tuesday we get back from break. This is the second biggest unit we do. The first one being the circle unit, unit 10. All right, so this is a long unit. So when you get your packet tomorrow, I'm showing you, oh, look how huge this is. This is like a novel. Yeah, it will be. All right, because we're going all the way to January 4th with this unit. Okay. We just spent the last 2 units talking about what? Yeah, triangles. I think we're good now. We know enough about a triangle. We're good. So I think it's time to graduate to quadrilaterals. That's the name of this unit, by the way. I know it's not on your notes anywhere, but quadrilaterals. How many sides now? 4. So yeah, what are 4-sided figures you're aware of? Square, rectangle, rhombus. That's it. Anybody parallelograms? Trap, azoids, and kites. Those are the 4-sided figures we're going to study this unit, and they're all called quadrilaterals because they have 4 sides. We're going to start that tomorrow, though. Here's what I want to do today. I'm going to take any sided figure. How many degrees are in a triangle? 180, right? Anybody know in a quadrilateral? Anybody know that one? 360, yeah, and then probably it ends right there. What if I said a 10-sided figure? We're not going to know, but you will by the time you walk out the door today. That's what I want to do with you today. If I have any sided figure, how many degrees are in it and how many degrees are outside it for its exterior? First thing, let's drop some knowledge on me. Let's go through all the different polygons you're going to be responsible for. 3 we know already, that's a triangle, right? 4, that's a quadrilateral. You can say rectangle, rhombus, but those are all types of quadrilaterals. Quadrilateral, oh, and I will say, period 2, the break stopped right here for some reason. I was shocked that we all just stared at each other in silence. 5, pentagon. I know you guys have more people than they do, but 6, hexagon. This usually produces a little more silence. 7. What do you got? Heptagon, or sometimes, anybody have another one? Because it's sometimes referred to septagon, but I'll go heptagon. Griff gave it to me first, so heptagon. How about 8, and don't say a stop sign? That is an octagon. Personal favorite of mine coming up, the 9-sided figure. Nothing? So go ahead. You're like the library, Griff. Go ahead. Nonagon. Is that just some trait that you have there, Griff? Like with me, it's state capitals. You're the polygon guy? Okay. How far does it go up to, though? 10? Did you know that one, Griff? Yeah, you did. Decagon. All right, this is really, really where you make your money now. 12. You're going to disappoint me now, Griff? No 12? Nothing? Okay, so you go up to 10. That's your limit. Yes, Jonah?
Is it dodecagon?
It is a dodecagon, yeah. That's what you're responsible for right there. Okay? Anything bigger, we get a little lazy. We'll get a little lazy. 20, it's got a name. Personally, don't care. We're going to go with 20gon. Okay? That's what we're going with. And anything bigger than 12, we're going gon. So n-gon. Okay? And again, what's the n going to tell us? That's the number of sides. Whatever number's there is the number of sides. All right? All right, next, some vocabulary terms. Diagonal. Why is he doing diagonal? We know what it is. All right, well, here's the issue, though. You probably only know what it is in a quadrilateral. Hey, diagonal, I connect the corners. That's what you tell me. Right, at this point in your career, connect the corners, diagonal. Well, all of these have diagonals, too. All of these. Draw yourself a little pentagon. Oh, God, pentagon. 5 sides, relax. Okay, a pentagon has diagonals as well. It connects a vertex to a non-adjacent vertex. So if I start here at a vertex and connect it to another non-adjacent vertex, that's a diagonal. That's a diagonal. You can do it again. Make a couple of them. Why not? Go nuts. Vertex to non-adjacent vertex. Oh, well, Mr. Carlino, what if we connected 2 adjacent vertices? It's called a side. Okay. Good luck, though. It's called a side. All right, everyone good? Diagonals. Not just in a quadrilateral. Any type of figure. Except for a triangle, I guess. Everyone understand why I can't do it in a triangle, because I can never connect 2 non-consecutive vertices. All right, 2 types of polygons. Convex. That is the type of polygon you have seen your entire life, which is every diagonal is located inside the polygon. Like my pentagon I have up here, my quadrilateral, those would be considered convex, because all diagonals would be inside. Now I know where the thinking's going. How in the world could you get a diagonal outside? That's called a concave polygon. Here's the problem right now with your thoughts, and I want to eliminate this thought process. Everyone says polygon, and you think just your shapes. Right? You just think your basic shapes, but here you go. I can draw this bad boy. It's a polygon. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. It's a 7-sided polygon. It's not what you're used to, but that's probably because you've never seen concave. Do you guys see a diagonal I could draw on the outside of this figure? Do you see one I could draw on the outside? Darn right you can. So if I can draw a diagonal on the outside, that's called a convex polygon. All right, convex. You've never experienced them, but they're polygons. Just not concave. That's concave. You've always experienced convex. Any questions for the vocabulary before we get to the big meat of today? So how many degrees in a dodecagon? How many degrees in a 20gon? You're about to find out in your group. You're about to find out in your group. All right, help me fill out my table. Help me fill out my table. We're going to examine 5 figures and see if there's any pattern how I can find how many degrees in each figure. All right, make it easy first. Triangle. There's our first figure. Triangle. Triangle. Make it easy on you on this first one. Number of sides, we know. 3. And I know this seems like a strange answer, but the number of triangles you see is only 1. You see the triangle. So how many degrees in a triangle? 180. All right. I think you'll pick this up after I do my next figure, which is a quadrilateral. We know number of sides is 4. No big deal. All right, here's what I mean by number of triangles now. Start at any vertices. How many triangles can I make just coming from this vertex only? I'm not allowed to go in another vertex. How many triangles can I make from this vertex only? How many? 2 triangles. So you're only allowed to start at a vertex and continue with that one. Ready? How many degrees in each triangle I just made? Ready? There's 180 degrees in this one, 180 degrees in this one, for a total of how many degrees in the figure? That's where the 360 comes from. Okay, that's where the 360 comes from for any quadrilateral, because you can make 2 triangles out of it. You're going to do the same exact thing in your group for the next 3 figures. And I want to know, is there a pattern between the number of sides and the number of triangles you can make? All right, so fill in the rest of your chart for the following figures. Pentagon, hexagon, and octagon. Okay, fill in your chart. If you have to draw it out, draw it out. See how many triangles you can form from one vertice only. Go ahead. Talk it out with your group. How many can we make? Okay, pentagon. You know, 5 sides. How many triangles did it form? Formed how many triangles? 3 times 180 degrees in each of them. So that is 540 degrees in every pentagon. All right, hexagon. 6 sides. How many triangles? 4. So 720 degrees in a hexagon. And finally, octagon, 8 sides. How many triangles did it form? 6. Yes, 6. How many degrees in every octagon? 1080. Do we see any relationship? Because here's what I'm going to ask you now. I'm going to give you something you can't draw and determine the number of triangles. How about a 30gon? 30gon? 30 sides. How many triangles do you think it's going to form based on the pattern you've just established, Caitlin? 28. And what are you going to do with that 28 to figure out how many degrees in a 30gon? Multiply by 180. There we go. So how many degrees in a 30gon? 5,040 degrees. So in your own words right now, I don't want to put a formal formula down, but in your own words, how do you find, I give you any excited figure, how do you find how many degrees are in it? In your own words. What did we just do up here to find all these here? Jonah, go ahead. In your own words, what do I need to do?
It would be the number of sides minus 2 times 180.
How's it sound? Sound good? Because that's exactly what I'm about to write down. All right, for the polygon angle sum theorem. Here you go. Sum of interior angles is equal to, Jonah, one more time.
The number of sides.
Okay, which will be different every problem. So I just can't put a number in right now. What I'm going to put in is an n. And n represents number of sides in my formula. Number of sides. So go ahead, Jonah. It's going to be number of sides.
Minus 2.
And then?
Times 180.
There you go. If you ever want to find how many degrees are inside a figure, there's the formula. 180 times number of sides minus 2. Great job. Great work. All right. My philosophy today, I'm not doing these problems with you. I want you to use your group, use your heads there, and try to do problems 1 and 2 right now. Okay? 100 sides, how many degrees? And then what's the missing angle of number 2? Talk to your group, because I'm just going to call on somebody. And not only are you going to tell me the answer, you're going to go through it with me as well. All right, so go ahead. Problems 1 and 2. Okay, explain to me number 1 then. Not just the answer, but how we got there. Here we go. Let's hear from 19. Got lucky there. Some of you. Go ahead, 19. How do I get here?
You do 100 minus 2, which is 98.
And then times it by 180. They use the formula pretty much. Just plug in 100 for n, and then what do we have? What do we have here?
17,640.
There we go. A lot of degrees, huh, in a 100-sided figure. Now, number 2, what's the missing angle? Not what it totals up to, but what's my missing angle for number 2? Let's hear from 8.
You do 180 times 5 minus 2.
Good. 5 sides. Got it. So there's how many degrees here?
540.
Yep.
And then you add up all the sides that are in the thing, and that's 437. And then it's 540 minus 437 minus 437 and 103.
103. 103, yep. Any issues? 5 sides, 540 degrees. We're okay? All right, so that's everything inside. Can we talk quickly about what about on the outside? The exterior angles of a polygon. 1, 2, 3, 4, 5, 6. All right, I'm going to break you guys up. All groups are going to be combined. So I got group 1, group 1. Group 2, group 2. Group 3, group 3 in the back. All right, here's what I want you to do very quickly in your group. You're going to take your group's figure. Find every exterior angle. So group 1, you got 150 interior. What would be its exterior? You got 85 interior. What would be its exterior? 90 interior. What would be its exterior? Then I want you to add them all up, please. All I want from each group is what do your exterior angles add up to? Go. So find all of them first, and then add them all up for me.
You get 360.
I don't want to know what they are. I just want them all added up. What's the sum of your exterior angles?
Is that all the angles that you have? How'd you get 150?
Oh, sorry, 60 plus 90 plus 25.
Okay, let's report back. Group 1. All your exterior angles added up to? 360? Group 2?
360.
Group 3?
360.
What'd you guys just prove? How many sides did this one have? 5, 4, 3. Doesn't matter how many sides a figure has. Yes, no? No. What's always true? The sum of the exterior angles. It's no formula, right? What's it going to be equal to? Just proved it here, guys. Just proved it. I don't care how many sides it has. It's always going to equal 360 degrees. All the exterior angles added up will always be 360. 30 seconds. Answer question 3 with your group. 30 seconds. Answer question 3.
Oh no, I see it now. You don't know it's like.
All right, there you go. 36 sides. Number 4, what do they all add up to? Yeah, guys, I don't care what number I put there. You add up all your exteriors, they're always 360. All right, it's time to get nuts. This is where we get to an honors level now. One more vocabulary term for you. And that is what we're going to be dealing with now. A regular, when a polygon is regular. Before I give out the definition, what do you think? Even if it's wrong, who cares? You have the guts to try. What do you think? If a polygon is regular, that means what? Go ahead, Charlotte. I like to start. All sides are equal. That's one of a couple properties. If a polygon is regular, all sides congruent. Anybody want to build off that? All sides are congruent. Yep. Paul? Now let me be careful here. I'm just going to break that off. All interior angles equal. And all exterior, I don't want to say all angles because everyone thinks every single one is the same, but they're not. All exterior angles are congruent. All right. So if you want a quick visual here, and I don't want you to draw it, waste time. Here you go. If I have a regular pentagon, take a look. All right, that's a regular pentagon, and also I can do this to the sides. There's a regular pentagon. Are you ready? We're going to go question by question. You have about a minute, a little over a minute to answer it with your group. You got 20-sided figure. It's regular. All the angles and sides are equal. 20 sides. In your group, find one exterior and one interior angle. And how are you going to do it? Talk to each other. Let's go. You know it's regular. All the exterior and interiors are equal. It's got 20 sides. How do we get one interior and one exterior? We're going to get harder as we go. Start with the interior or the exterior. I don't care. You start with whatever one you want. Let's go number 9. You want to start with the interior or exterior? Interior? All right, go ahead, Shannon. How'd you find it? Okay, so I believe what we're doing here first is finding the total amount of degrees inside. And what was that equal to, Shannon? Okay, so there's 3,240 degrees in a 20-sided figure. How did you find one interior then? Good, divided by 20. So what's one interior angle? 162 degrees. Great job, great job. Everyone's good, 162. All right, how'd you find an exterior then? A couple different ways. Now that I know the interior, that changes the game. A couple different ways I could do the exterior. Your show, 13? 13? We got a new 13? There we go.
You subtract 180 from 162.
Interior and an exterior will always be supplementary in a polygon. So exterior, I could do 180 minus 162 to get 18. Could you also do 360 divided by 20? Yes, you could. That's the other way to do it. All good? All right. Next up, another minute. Now find me the number of sides if one exterior contains 120 degrees. Ooh. One exterior is 120. How many sides must there have been? No guess and checking. No guess and checking.
Okay.
I'll start with 6 sides, 7 sides. No guess and checking.
Yeah. Okay, wait, hold on, let me think. I'm like right there.
So you just multiply, or wait, no, the extra is always equals to 360, so 120 times 3 is 360.
No, it's just
60 the interior is 180.
okay, wait. 60 times 3 is 180. So it's a triangle. Everyone agrees? Okay. How do we write that down?
So I did 120, well 360 divided by 120.
Okay, talk to me.
And then you can just check it by doing 60 times.
15? How do I find this here?
So we did 360.
Okay, so where's the 3? You're correct. Where's the 360 come from?
So in the number 4, we did 360 divided by the number of sides equals the exterior angles. So we just did that.
360 is what they all add up to. And what I want to figure out is how many of those 120 degree angles fit there. And how many were there? 3. Honors question. What type of triangle is this?
Equilateral,
Thank you. Why?
because all the angles are congruent.
Not only is it a triangle, it's regular. So that must mean all the angles and all the sides. Correct. Equilateral triangle here. All right, go. You guys are on an even tougher one. Now you know an interior. How do I find the number of sides? Whoa. Ooh,
Now
now
it's gonna be
you know the interior. How do I find the number of sides?
So when you subtract, you get an exterior of 20, right? Alright, so our interior we have our
Getting challenged.
So then would it be
180 divided by
because 180 minus 160? Okay, 180 divided by 20 times equal to 9. So then would that be 9 sides?
See the exterior and then the interior.
Yeah, that's what I feel like it would be.
interior. Because it would be 360. Yeah.
360 divided
How do I handle the interior now?
Oh wait, that's not right. Sorry. 13, 130.
Wait, what?
360 divided by 20.
It's 18.
Oh, I'm sorry. I don't know what I'm doing.
So then would it be
Okay, let's talk.
160 times 18?
Now what do I do if I give you the interior? How do I find the number of sides? Talk to me here. 4. Griff, talk to me. How do we find the number of sides?
Subtract 160 from 180 because that's the interior, because they're supplementary.
Okay, so what we're doing, just so everyone knows, we're going from the interior to the exterior, which is 20. Why do I always, if I can, why do I always want to deal with an exterior angle? What do you know, Jonathan? Every time. It's always they always add up to 360. Always. Interior, different story. So Griff, back to you. What can I do with this 20?
Divide 360 by 20.
There you go. Number of sides equals 360 divided by 20. So this had 18 sides. Yes, indeed. All right, toughest one yet to finish class. You know an exterior. We knew an interior. Now you know what all the interiors add up to. How many sides? No guess and checking. No guess and checking.
Actual measurement of it is 2,000.
All the interiors add up to.
So that's.
Because if you guess and check, I'll put one on the quiz that ends up being like 150 sides. Good luck.
Yeah.
So
If you know the interior angles add up to 2,880, how many sides?
Right? Because like we have one part, like we're missing one part, then we also have that other part that we would need. So by doing that, you're finding how many sides that is equal to. Right? Well, yeah, so that's gonna be
We're just trying to find the triangles. I mean,
Oh, you're finding the triangle thing, you're finding the 20.
So like basically how I'm thinking of it as in the past, instead of the equation, I wouldn't be able to fill in like the number of sides that we normally have. So instead of filling in the sides, I have the actual whole degree that the actual polygon is. So I'd fill that in instead.
Okay, up here, so we can finish on a strong note. The sum of the interior angles of a polygon. That was the first thing we talked about today. And that was equal to 180 times n minus 2, wasn't it? What's this equal to in this problem? 2,880. So I set it equal to 2,880. Because that is the formula for the sum of the interiors. In all seriousness now, because every year I get these crazy, oh, add 2 now. What are you guys doing now? How are you solving for n now? I could distribute the 180, or anybody do anything different? Caitlin? You can divide the 180. Either way, distribute or divide the 180. It's up to you. You can't just add 2 though. No. So n does come out to be 18 sides. Before we close up shop, I am not accepting just answers tomorrow for the homework because you went on Classroom and did it. Look, you guys can see we got to show work tomorrow. All right, so that's what I'm going to be looking for if you want an interview. Showing work, not just answer keys.